Assalamualaikum and good evening. So today we have been given an assignment to talk about topic that related to thermodynamics. So as a group, we have been discussed about several things and we have been decided to talk about heat pumps. So firstly, I will talk about the introduction of heat pump. So heat pumps, air conditioner and refrigerator utilize heat transfer from cold to hot. They are heat engine run backwards. So we say backwards rather than reverse because except for Carnot engines. All heat engines, though they can be run backwards, cannot truly be reversed. So heat pump is a device which applies external work to extract an amount of heat from cold reservoir and deliver heat to a hot reservoir. So it's subject to the same limitation from the second law of thermodynamics as any other heat engine, and therefore the maximum efficiency can be calculated from the Carnot cycle. So usually it characterized by a coefficient of performance, which is the number of units of energy delivered to the hot reservoir per unit work input. So then I will talk about the basic principle. First, the heating process. So for the heating process, the liquid refrigerant will absorb heat in the evaporator from the outdoor air and turning it into a gas. Then it will go through the compressor, which will raise the refrigerant pressure of the gas and increasing its temperature. So the third is the hot gas will flow through the condenser coils inside the space to be heated, and since it is at a higher temperature than this space, it transfers heat to the room and condense back into a liquid. Then the liquid will finally flow back through a valve that reduces its pressure in order to cool it down so it can be repeat the cycle. Then the second process is a cooling process that will go through in the heat pump. So the first process will go through at the evaporator. The cold refrigerant will absorb heat from the hotter room in the evaporator so that the room will cool down. Then it will go through the compressor. From the compressor will go through a process to increase its temperature. Then it will pass through the condenser coil and transfer this heat to the outside air. And lastly, it will expand in order to decrease its pressure and cool down to the below room temperature to repeat the cycle.
Hi, Assalamualaikum. My name is Muhamad bin Khairul. I'm from the MMV S1/1. So for our group assignment for thermodynamics, we choose to take a heat pump, which is the topic of the heat pump. Okay. So as we all know that heat pump is a process which work similar to an air conditioner, aircon or refrigerator, but in reverse for heating cycle. And there are four main components that are important in the process of heat pump. And the four main components are compressor, condenser, evaporator, and refrigerant. So today I would like to talk about compressor. So what is compressor for heat pump? So the compressor is the core component of a heat pump. It is also the primary factor that determines whether the heat pump is good or bad. And why does I say compressor is a core component in the heat pump? It is because compressor keeps the right pressure drop between evaporator and condenser to maintain the proper phase change temperature to interact with the external to the heat pump source. For a better understanding, the refrigerant pump compressor is to maintain the refrigerant flowing inside the heat pump and to increase the pressure in which the refrigerant is compressed into a gas. Okay, let's move to our next slide. Okay, so operating principle for the heat pump is heat pump transfer heat by circulating substance called a refrigerant through a cycle of evaporation and condensation. A compressor pump the refrigerant between two heat coil, two heat exchanger coil two heat exchanger coils in one coil. The refrigerant is evaporated at low pressure and absorbs heat from its surroundings. The refrigerant is then compressed en route to the other coil, where it condenses at high pressure. At this point, it releases the heat it absorbed early in the cycle. A compressor in a heat pump application operates in the same way as in compression refrigeration plant. Actually, many technicians affirms that you can use AC system compressor on a heat pump or vice versa without any problem. However, heat pump and air conditioner have different thermal loads and varying working conditions. Okay, for our third slide is type of compressor in the heat has been used in the heat pump. First is the reciprocating compressor. Reciprocating compressor is called as positive displacement compressor. This compressor works by suctioning, discharging, and then extruding the water vapor or refrigerant. These are one of the most effective and fastest when working, and they can vary in the number of valves, number of cylinders, and amount of compression stages. So what does it mean by positive displacement compressor? Positive displacement compressor drawn in and capture a volume of an air in the chamber. They can reduce the volume of the chamber to compress the air. Okay, for our second is rotary compressor. Rotary compressors are the smaller of the bunch, which use a rotating piston to compress the refrigerant. This also helps to reduce the noise at the compressor make and minimize the process of compression in just suctioning and pressuring the coolant. Okay, lastly is a screw compressor. Screw compressor very similar to rotary compressor. This type of compressor consists of suctioning, transporting, and extruding the refrigerant. This compressor, in contrast, used to helical rotors to move air from the one side of the heat pump to the other. While doing the compressing process, these features make the screw compressor much more reliable and often much more efficient than others. Yet they are most used in heat pumps with large outputs, meaning that they work better for large operation instead of small one. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Adam Aiman bin Daud. I'm from BMMV Section 1 Group 1. For the presentation, I will explain about condenser in heat pump. First, in system involving heat transfer, a condenser is a device or we call unit used to condense a gaseous substance into a liquid state through cooling mode. By doing that, the latent heat is released by the substance and transferred to the surrounding environment. Second, a condenser is designed to transfer heat from a working fluid, as example water in a steam power plant, to a secondary fluid or the surrounding air. For example, that everyone have at their home is a refrigerator. A refrigerator use a condenser to get rid of heat extracted from interior unit to outside air. This means when we keep our food or anything in the refrigerator, from the fruit or the outside heat in the refrigerator is extracted out by the condenser. And other than that, the example is air conditioning, industrial chemical process such as distillation, steam power plant, and other heat exchange system. Next, uh, the condenser as a component in heat pump cycle. The heat pump condenser pass through another network of heat exchanger coils. The transferring heat from the refrigerant cycle to the water heating circuit, or we can call wet heat distribution system. This heated water then circulates around the radiators and underfloor heating system in our home and giving off heat as it goes. That's mean we can see this process when we feel under the refrigerator. We can feel hot at the place. Lastly, heat pump condenser in cooling mode. What condenser do in cooling mode? When heat pump is in cooling mode, the process reverse. The evaporator and the heat pump condenser effectively swap roles. The compressor passes cold refrigerant through the indoor heat exchanger coils, which in turn runs cold water through your wet heat distribution system. And the evaporator passes hot refrigerant through the outdoor heat exchanger coils and transferring heat outside. That's all from me for the condenser in heat pump. Thank you.
So I'm going to present of the main component of heat pump, which is expansion valve. Expansion valve is a material device that feeds refrigerant to the evaporator, lowering its pressure from the condenser to other evaporator in order to keep suitable temperature for heat. The expansion is an essential component in almost every refrigeration cycle, and the thermostatic expansion valve is the most commonly used within HVAC systems. So how does it work? The valve holds back the high pressure liquid refrigerant from the condenser and controls how much refrigerant can pass into the evaporator. The valve decreases the pressure to allow the refrigerant to boil at lower temperature. The high pressure liquid refrigerant is forced through a small orifice, which causes a pressure reduction as it passes through. During this pressure reduction, some of the refrigerant will vaporize and the rest will remain as liquid. This mixture of liquid vapor refrigerant is sprayed into the evaporator, where it will absorb heat from the air or water, which surrounds the pipe. In this example, as the refrigerant passes to the evaporator and is exposed to more thermal energy, it will undergo a complete phase change and will become a saturated vapor towards the end of the evaporator coil. During this change, there will be no temperature change because of the latent heat. Instead, it will increase in enthalpy and entropy. The refrigerant will continue to pick up thermal energy, and when it does, after the phase change, it will then start to increase the temperature. This superheats the refrigerant vapor. The sensor bulb of the expansion valve is monitoring this temperature to control the refrigerant, the main valve body. Next is evaporator. Evaporator is also an important component together with other major components. It acts as a heat exchanger that transfers heat from the substance being cooled to a boiling temperature. There are two types, which is forced convection type, natural convection type. So an AC evaporator coil, also called the evaporator core, is the part of the system where the refrigerant absorbs heat. It's where the cold air comes from. With a heat pump, the process reverses in the winter, and the evaporator coil expels heat from the refrigerant into home instead of absorbing heat and taking it outdoors. Most heat pumps have auxiliary heating elements that are part of the evaporator coil component to supply heat when temperature fall below a certain point. So, how does it work? As the SU runs, the compressor pulls cold low pressure liquid refrigerant through the tubing in the evaporator coil. Before entering the evaporator coil, the refrigerant passes through to a special valve. This valve releases pressure from the liquid refrigerant, which rapidly cools it. The liquid refrigerant leaving the expansion valve is quite cool, which is what allows it to absorb heat from the air. The expansion valve also controls exactly how much refrigerant flows to the evaporator. More advanced expansion valves such as thermostatic expansion valve, or being known as TXV, can manually control the flow to improve the system's overall energy efficiency. As the refrigerant flows, the blower fans draws hot room over the evaporator coil. The refrigerant absorbs heat from the passing air, and as it does, it warms up and evaporates. When the water vapor in warm household air hits the cold evaporator coils, the water vapor condenses into liquid form and drips down into the condensate pan, which drains the water away outdoors. This is how evaporator coil reduce the humidity in home.
Assalamualaikum and salam sejahtera. My name is Asyraf Arusydi bin Affendy and I'm from 2 BMMB Section 1 Group 1. So, for this presentation, I will explain about the coefficient of performance and thermodynamics of heat pump. Okay, what is the meaning of coefficient of performance? The coefficient of performance is an expression of the efficiency of heat pump by using the first law of thermodynamics below, where COP is equal to Q hot divided by W is equal to Q cold plus W divided by W, where W is work done and Q hot and Q cold is an absolute value. When calculating the COP of heat pump, the heat output from the condenser is compared to the power supply to the compressor. COP is defined as the relationship between the power that is drawn out of the heat pump as cooling of heat and the power that is supplied to the compressor. For an ideal heat pump, it can be derived that COP is equal to T hot divided by T hot minus T cold, where T stands for temperature. According to the above formula, the maximum achievable COP for T hot is equal to 35 degrees Celsius, which stands for 308 Kelvin, and T cold is equal to 0 degrees Celsius, which stands for 273 Kelvin, will be 8.8, but in reality, the best systems are around 4.5. As can be seen, the COP of a heat pump system can be improved by reducing the temperature difference, where T hot minus T cold. Therefore, reducing the output temperature, T hot is very efficient, but requires very efficient heat transfer from heat pump system to surroundings. COP is indicated without units. Therefore, the produced heat and the supplied power employed the same units during COP calculation. So, that's all for me. Thank you.